Hey guys, this is just going to be a quick video as a refresher of all things factoring. I know some of you still hate factoring or can't remember a lot of the little ins and outs, so I wanted to go through and make sure we remembered some stuff. First thing you always do when you're told to factor is to look for the GCF, which is the greatest common factor. So look for numbers and variables that can be divided out of all of these terms. So hopefully you see that a 3 goes into 3, 15, and 9. The greatest amount of x's that I can pull out is just an x to the first. That's what we see here, right? Invisible 1, invisible 1. And then the greatest amount of y's that can be pulled out is just y to the first as well. So the 3xy is going to be factored out. Factoring just means divided. So when I divide this out of the first term, it's only going to leave 1x behind. Plus, when I divide the second term by 3xy, it's going to leave a 5. Let's see. X and x, those will go away. Y squared minus 3 into 9 is 3, and then the x will go away, and then y to the third. All right, so you always want to check inside of here to see if that could be broken down even further, but this is not something that we'll factor further, so that would be my final answer. All right, so now let's move to the second type. All right, so the guess and check method for factoring a quadratic. So what you're going to look for, same as before, always look for a greatest common factor, because this does not look like a quadratic right now, but it's because there's a w present in every term. Also, these are all even numbers, so it looks like I'm going to try to take out a 2w to start the problem. And I'm going to divide that out of all three terms. So 24 divided by 2 is 12, and then w to the third divided by w is w squared. Plus 2 goes into 10 5 times, w into w squared once, minus 2, and then w into w, those would be divided out, so they would cancel. All right, now I'm going to look to the inside, and this is definitely a quadratic, something with a squared, something with a normal, like to the first, and then a constant. And this type of factoring, typically, if it's going to factor, they don't always factor, but if it's going to, it's going to look like this when all is said and done. So what I do is I look at the back first. And I think what times what makes a 2, you know? Well, the only way to make a 2 is a 2 times 1, right? And then, so that's going to be what's at the back of these. And then I look at the front, and it's a 12w squared. So I have to think, what can make a 12w? Well, you've got 12 times 1. You've got 2 times 6, and then you've got 4 times 3. And this is why it's called the guess and check method. I'm literally going to guess one of these combinations, and I'm going to fill them into my parentheses. And then what you're going to do is basically FOIL in your head to see which one would make what's above. So we're looking for that 5 in the middle after we FOIL it out. So this is sort of like an afterthought, this circled 5w. So I'm going to try the 4 and the 3. 4w, 3w. And what I'm going to do is then just, like I said, I'm kind of foiling in my head. I need to check the outside times the outside and the inside times the inside. So 4 times 1 is 4. 2 times 3 is 6. Well, a 6 and a 4 cannot make a 5. You know, like 6 plus 4 is 10. 6 minus 4 is 2. That is not a 5. So that basically means I don't have the right mindset. So usually what I do is before I pick a different combination of numbers, I just switch the places of those two. So I think I had the 4 here. So I'll put the 3 there now and the 4 there. And then I'll try again. 3 times 1 is 3. 2 times 4 is 8. Now, can an 8 and a 3 make a 5? Why, yes, they can. If the 8 is positive and the 3 is negative, they will add together to make this term that's in the middle. So I know I have things in the right place. I just need the correct signage now. So if I need the 8 to be positive, that came from these two. So I need the plus on the 2. And if the negative needs to be on the 3, I need to put it here so it could make that happen. So now I feel like I factored it correctly. All right, and that would be my final answer. Okay, moving on. Difference of squares. This is a special kind of factoring. Difference of squares, what you want to do is you always want to look for, do you see perfect squares, and do you see a subtraction sign in the middle. Now, right now, I don't see perfect squares, but remember our rule. Is there a greatest common factor? Yes, there is. The number 2 goes into both of those. So let's take out a 2, and then it turns into this. Now look at what we have. Is this a perfect square? Is this a perfect square? And the answer is yes. And if you're wondering, what does she mean by perfect squares? Well, guys, those are the numbers that have a perfect square root. Square root of 1 is 1, square root of 4 is 2, square root of 9 is 3, 16, 25, 36. These are your perfect squares, okay? So what I'm going to do is leave the 2 there. I'm going to throw down my 2 sets of parentheses, and now I'm going to take the square root of each of these. So the square root of 16y squared is a 4y. So that goes in the front of both. The square root of 1 is 1. That goes in the back of both. And you need a positive and a negative. And what that does is when you do FOIL it out, if you wanted to check your answer, it makes the middle term cancel, and it does turn back into this. So that would be factoring a perfect square. Or, sorry, a difference of squares. Okay, moving on to the next type. How about factoring a cubic? All right, so factoring a cubic, I'm going to use a method that some of you use for quadratics. It's called factoring by grouping. And the way I do this is I usually don't rearrange the problem at first. Sometimes you have to rearrange things to make this work. I usually just try grouping the first 2 together and grouping the last 2 together, and then I factor each separately. So I basically look for the GCF on each of these. And so when I look at that first set of parentheses, it looks like a 4 can go into those and an x squared. So that looks like the greatest common factor. So if I take out a 4x squared from here, it leaves behind a 2x. If I take out a 4x squared from here, it leaves behind a 3. Then I go to my second one and I think, what's the GCF? Well, you may think there's not a GCF, but I don't like those negatives, so I'm going to actually factor out a -1 from both of those just to turn them positive. And the reason I knew to do that is because the goal here, guys, the goal, so that you know if you did it right, is that these are going to match. And if they do match, you're on the right track. Now, let's say they don't match, okay? What that means is you may have to come back up to this first step and like move some people around, you know, just kind of like rearrange the terms. And if you rearrange the terms, then you could try again, and a lot of times it works out really nicely. Okay, so what happens now? Well, now that you've got these to match, you take the factor that matches and you factor that out to the front. So I'm going to take this parenthesis and pull it out front, and then think, what does it leave behind? Well, it leaves behind a 4x squared minus a 1. Okay, and then I have factored that. Now, always check these because I just looked down, and actually this is going to factor again. And the reason this is going to factor again is the one we just did above. I see a minus sign. This has a square root, and that has a square root. So my final answer is actually going to be square root of this is 2x, square root of this is 1. 1 gets a plus, 1 gets a minus. This is actually our final factored form. Hopefully y'all saw that happen. I'll leave it there if not. Okay, and then do I have any more kinds of factoring? Oh, of course I do. Factoring a perfect cube. Okay, this is a formula I don't often remember. I have to think really hard. But basically there's a couple. This is just like a template. If you see something cubed and another something cubed, okay, you can break it down as follows. Okay, or if there's a minus, okay, a subtraction sign, not a minus, if there's a subtraction sign in the middle, the signs will just change, but the template stays the same. So basically the way I remember it is whatever's in the middle matches the first one, and then you have to switch the next one, and then the last one is always positive. Okay, so what you do is you recognize that this is a perfect cube and this is a perfect cube and there's a plus sign. So I'm trying to break it down into this, and I just need to figure out what my A and my B are, okay? So basically A is the cubed root of whatever's in the front, and B is the cubed root of whatever's in the back. So my A, well, the cubed root of 8 is 2 and the cubed root of x cubed is x. B, the cubed root of 27 is 3. So now that I have my A and my B, I'm literally, guys, just going to substitute these A and B into these A's and B's. 2x plus 3. And then I need to do 2x squared. Now be careful because 2x squared is the entire 2x squared. Okay, so what that means is you've got to square each of them. So it's really going to be 4x squared. Where'd my pen go? It's really going to be 4x squared. Minus a times b, that's a 6x. We're multiplying those, plus b squared. 3 squared is 9. So this right here is going to be my answer. Now, if this breaks down again, like if this factors down again, please do so. I need to think about it. I could guess and check it. Let me see if it's going to work. Let's see. I don't think it is. No, it's not. It is definitely not going to factor. So I'm not going to even try. But I just wanted to let you know that's what you should do, is always look at that and think, is it going to break down again? Okay, let me try. And that, folks, is factoring review, fast and furious, all of Algebra 2 factoring in 12 minutes. Nope, 11 and a half minutes. So hopefully that helped and made sense. If not, you know, hopefully you have time to ask me some Q&A in our online class. Thanks a lot.